In this question here, we see there's a graph to start us off. So we start with our Oizerga analysis. So here's our origin, our 0, 0. Y-axis is momentum, x-axis is time. The intercepts we see here, that P0 is positive. It's a positive number. And this intercept here, we see that the P equals 0 at that time. And if P is mv and P is 0, then the velocity is 0 at that point in time. So those are our intercepts. We can read momentum time. It is the axes. The gradient is delta P over delta T, which is the definition of force. And the area is P times T, which is kilogram meters per second times seconds. Kilogram meters is like mass delta X, and that's not a known quantity or a quantity that we identify as one of our main concepts. So we've got a rubber ball traveling in a horizontal direction, strikes a vertical wall, rebounds from the wall. So let's take a look at our situation here. We've got positive momentum, so the ball is moving in this direction. So if this is positive direction and this is the negative direction, the ball is moving this way, it strikes a vertical wall. All right, so, and we know this because the momentum is positive, which means the velocity is positive. So if it's moving to the positive direction, it hits a wall, this must be the arrangement. Rebounds at right angles to the wall, like so. It shows its momentum with respect to time. And if you notice here that the momentum and the time, it seems like there's no time of interaction or impact. So this thing bounced off without any deformation at all, like we saw in the lessons. And kind of which of the following statements is true? Shaded area. The area is m times delta x. Equal to the force. Wait a minute. The force is the gradient. This is off. Shaded area equal to force. That's out. Gradient is equal to the force. That's true. Gradient is equal to the force exerted by the wall on the ball versus the ball on the wall. So what we notice about the force is, first of all, the force is negative the entire time. The slope is negative and it's constant. So a negative force means it is pointed in this direction. So if we think about that red force, that ball coming in, the force in that direction would cause it to stop and bounce off and go back toward the left. So it looks like that's the case. The gradient is equal to the force exerted by the wall on the ball, which is choice C. The ball on the wall force would be in that direction, positive direction, which would be a positive slope. So that's why 116 is choice C.